So if anyone misses it or you guys want to come back and like watch it again, or you just really like hearing my voice, you can watch it again. We'll upload it and like send a link out and everything. But welcome to the Western Engineering Satellite team. Sorry that this had to be online. We were so pumped to like take over the ASAP atrium and have this awesome thing. And then London said no. London and Western said no. So we're here. We made it work. We'll still give you guys all the same information. All of our meetings and stuff will still happen in person, assuming COVID doesn't kill everyone. But this unfortunately just had to be online. So we'll continue as is. It'll still be just as fun. But yeah, let's get started. So it's probably pretty obvious from our name that we do satellites, but like, what really does that mean? What are we doing? So over the next 2 years, we're going to be building what's called a CubeSat. It's a very small satellite, but it definitely packs a bit of a punch. And it definitely takes a lot of advanced math, physics, and engineering to really get working. Space is a very unforgiving environment, so there's a lot of stuff that goes into this. And so we're really excited to get building this. One of the payloads that's going to be on it is a camera. The idea is to take a picture of Western University from space, and that's sort of like our big end goal. That would be super neat to finally at the end of this have a picture from outer space of Western University. Be pretty sick. So our satellite's going to be launching on this rocket that's being built by Space Ride. This is a new company. It's a Canadian company as well. We've been working pretty closely with them over the past couple of months. We just got a bunch of stuff signed with them, and we're pretty much ready to go. So we're really excited to start working with them. A lot of good experience getting involved with like actual aerospace companies on this team. So really exciting stuff. But really, our big end goal is we just want to put something in space. We don't care how we get there. We don't care what the method is. We just want to have something in space. So we're going to work really hard over the next 2 years to make that happen. But there's a lot of work that goes into that to begin with. So a lot of people, they go, I know nothing about space. I know nothing about rockets. I know nothing about engineering. You might be a first year who just joined Western Engineering and you're like, how do I even help with this? I don't know how to do this. So why should I join West? So we as a team, we're open to just about any skill level. A lot of us, when we joined, didn't know anything at all. And we either self-taught or taught each other. That's sort of the great thing about the team is any skill level is welcome. If you've built thousands of satellites before, you'll fit right in. And if you've never built a satellite and don't even know how space works, you'll also fit right in. We've also got a variety of design sub-teams, which we'll go into in a second. But there's pretty much something for anyone. There's also a bunch of operations side if you're looking to do more non-technical stuff. But there's just about anything you could imagine in a project management capacity that you could be interested in, we have on this team. The other amazing thing that I push for just about any design team is you get to learn the majority of your degree before you actually do it. So you get to have fun while you're doing it, and then you go into classes in upper years and you're like, okay, this is freaking easy, like I did this years ago. So that's just kind of like an added bonus, which is pretty nice. From the professional side, we have a lot of good connections on this team. I'll go into it in just a bit, but there's lots of good connections you can make with various companies out there. Tons of amazing networking opportunities, both within the team, with our partners, with our sponsors, and with the people who perform our design reviews. And there's a great chance for leadership opportunities. A lot of people on this team will eventually get up into a leadership position, and that involves a lot of engineering management, as well as just general management that's really good to have on your resume. So from a personal and professional area, it's also a very good team to join. So some details about our team. We've got lots of advisors from Western, NASA, other universities, now from Space Ride. Definitely some like big companies with big names that are helping us accomplish all of this. And one of the big things we focus on is that we're students teaching students. We will get help from outside, but we really want to be teaching each other. The reason that's so important is because if you're teaching something to someone, you're going to learn a lot better, which is really important. Again, lots of cross-discipline work. You'll be working with people who might only have a financial background, might only have a marketing background, might have an engineering background, and you've got to be able to talk those different languages and still interact with those people in a successful way. And then final point, I really want to reiterate this because it might get a little daunting as we get through this, is that all skill levels and experience levels are welcome. Doesn't matter if you're first, last year, if you've been doing this for a long time or have no idea what's going on, we'll be able to help you get to where you're going. So we're going to start with the design sub-teams. This is generally why people come and look at some of the engineering design teams in Western Engineering. So we'll start with those. There's a bunch of different ones that sort of break down how the design of the satellite works. And so we'll start off first with the ADCS system. So I'll let Dea take over to talk about that.
Hi, everyone. My name is Dea. I'm the ADCS lead. And so ADCS stands for Attitude, Determination, and Control. And basically what that means is this subsystem takes care of determining and also like adjusting the CubeSat's position and the orientation in space. So as you can imagine, when the CubeSats first released into space, it's like spinning wildly and stuff. And so what we do is we take control of that. And if something like the camera needs to be oriented to face the Earth, that's also what our subsystem does. So why you should join ADCS is because it's a super unique subsystem. A lot of teams have a power system or structure system, but not every team has something like ADCS. So a very unique opportunity indeed. And also, you'll gain exposure to a lot of different things like microcontrollers. We're looking for people with software backgrounds for some of the programming that we're trying to get done, and also even designing things like magnet torquers, which I can talk to you about later on if you want to hear more. So there's lots of opportunities here, but I'd love to have anyone new on the team. Thanks.
Awesome. Thank you, Dea. I'm going to pass it off to Andrew, who's going to talk a bit about Hannah's position on the electrical power system.
Cool. So I don't run the electrical power system. The girl who runs it's not here tonight. Her name's Hannah. Electrical power system is cool. I mean, obviously it's not as unique as ADCS apparently, but you know, it's still really cool and definitely a useful skill that can be applied to lots of different situations. So even if you're not necessarily looking to get into space when you're done here, it's got lots of transferable skills for all kinds of different electrical projects. Our EPS system is going to be solar panels and a battery and some connecting bits in between. Those connecting bits in between are going to be confusing at times, and definitely the emphasis there is on efficiency. So it's about having an eye to detail there and figuring that sort of stuff out. I think that we have a pretty nice, easy learning curve for EPS. I think it's one of the ones that's sort of, if you're feeling a bit intimidated, I think it's a good one to try and see, because I think it's a really nice way to get into the team for sure. Right now, we're doing a lot of analysis on the work we're doing and how much solar energy we're going to be bringing in, and that's what we are doing the majority of our work right now. So a lot of that is programming. But there's going to be PCB design and schematics for all of the other boards that we'll probably be working with too. Power distribution is coming up, where we're going to be dropping all of our power to all the other teams. So it's a big, exciting team to join. You should definitely join EPS.
Thanks, Andrew. I'll pass it off to Danny to talk about the structure of the satellite.
Hi, I'm Danny. And yeah, so I'm in charge of structures. Basically, structures is what's going to hold the whole CubeSat together. So we're going to be working with all the other teams and making sure that we can fit everything they have into the CubeSat. So if you're interested in mechanical stuff, CADing, if you don't know what CADing is, we'd love to teach you CADing. It'll become very useful in upper years if you're interested in mechanical or Tron, or yeah, I think just those two. So yeah, if you're interested in 3D printing, manufacturing, all of that kind of stuff, that's what we do for structures.
Sweet, thanks, Danny. So I'm going to talk a bit about command and data handling. This is usually Kareem is in charge of this team, but he unfortunately has a lab happening right now, which is unfortunate. But I'll still go into some of the details of what command and data handling is, because this is essentially the brains of our entire satellite. We have all these awesome subsystems, but they don't really work unless there's something telling those subsystems what to do. So the command and data handling system is a PCB that's essentially a computer with some connections to all the other subsystems, and it's the brains. It says you do this and when to do it. There is a lot of software that goes into this as well. So people that are interested in doing any software design, We're using one of the industry standard softwares that's built by NASA, which is pretty interesting. We get to talk to a lot of people that work at NASA on the software. So it is pretty interesting stuff. For electrical design, there's definitely a lot that goes into building an entire computer on a PCB, especially making sure that it's tolerant to the environment and space. So a lot of interesting stuff happening there. We're going to be fabricating a lot of these boards this semester, or at least this year. So if you're interested in this sort of stuff, definitely check out the command and data handling team. But I'm going to pass it off now to Shelby to talk about communications.
Hey guys, I'm Shelby, and communications is pretty much what we need to talk to our satellite. We send and receive information and data, and that's what allows our satellite to operate, which is pretty important. So you can learn industry standards for long-range communication and RF communication as well on this sub-team. If that sounds really crazy and super difficult, don't worry, because we'll teach you. It's all a learning process. You don't have to have any experience. Some of the other aspects of communications that are pretty exciting is that you can design some PCBs, and that's going to be super interesting and useful for upper year courses, and also just industry. If you ever want to get into that, it's really good experience. So you should definitely consider joining communications because it is essential for the operation of our satellite.
How bad is that? You get to design the stuff that like talks to Earth. That's crazy.
Yeah, pretty crazy.
Okay, I'm going to pass it off to our last but not least design team. Andrew, you can talk a bit about analysis as well.
Yeah, so analysis is kind of cool. It's a pretty small team right now, mostly consisting of me and Shelby. So anyone who wants to join, you're always appreciated. It's a sub team that sort of works in and around all the rest and sort of isn't about designing a particular part of the satellite. It's more about assisting in analysis for everyone else. So right now we're working a lot with EPS on the solar simulations, but it's all about writing programs and learning new software to use in our design process. So as we're going to design and optimize the different parts and things that we're using, and eventually, to do things like plan the satellite operations and things like that. But that's a long way down the road right now.
Awesome. Thank you, Andrew. So just as a quick summary on design, first of all, it's super badass because you're actually building a friggin' satellite. There's not really many design teams or really anything you can do in a group that involves such like a complex vehicle. And we're essentially becoming rocket scientists, which is kind of cool. I think it's really interesting. This might sound super intimidating, but again, I want to reiterate that like it doesn't matter where your skill level is. It doesn't matter if you don't know anything about space. We have everything that you need to go from basically nothing to being able to actually build a satellite. And for those of you that are super experienced, don't worry. There's also lots of opportunities to take leadership on your own project or to like go off and just do your own thing. It really just depends on like what you feel comfortable with. And that's one of the big parts of our team. Okay, so we are going to jump into, oh, this title's wrong. I'm gonna have to fire someone. Onto the operations of the team. It's really important that we have a satellite that's built, but there's also a lot of things that go on behind the scenes that support our satellite to make sure we've got the money, we've got the marketing, we've got all of the licenses and everything like that. And there's definitely a lot of work that goes into that. So I'm going to quickly touch on these operations side. For those of you looking for non-technical roles, there's actually a lot of really interesting things and a lot of different moving parts at play. So if you're interested in getting into like a more complex project, this is definitely something that would be up your alley. So just to give a bit of a summary of what each of these teams do, we've got the external affairs team, which worries a lot about community outreach, talking to different corporations, really just like ensuring our interface with our surrounding community is strong. While we're going to be doing a lot of work on designing a satellite, we also want to foster that same learning environment for people who might be in high school or people who are just interested in learning about space. That's one of the roles we like to take, is trying to help people get excited about this sort of stuff. We've also got a lot of stuff that goes on internally. There's a lot of recruitment. So like this event that's happening right now took a lot of prep. A lot of the management that happens behind the scenes, that's all handled by internal affairs. And there is quite a lot that goes into it. So definitely check that out if you're interested in sort of seeing how the whole team works from a high level viewpoint. For marketing, as you can see, we love our merch. We love looking slick. We love making our team look cool. We're definitely doing a huge push on marketing just to have really interesting and cool promotional videos that can show off how cool we are, and people that are good at like artistic stuff, making nice websites, making nice logos, that sort of stuff. The marketing team does a lot of that work, and it's definitely something that we push hard on our team because we want people to know we exist. And then lastly, this is probably one of the bigger ones, is finances. It's not cheap to put a satellite into space, and we're essentially paying for everything, which includes the design and manufacturing of the satellite, as well as the launch. As I mentioned before, we're launching with Space Ride, and they've given us a bit of a discount, but it still is a very expensive endeavor. So there's going to be a lot of budget management, a lot of reaching out to sponsors, a lot of talking to corporations and getting their funding, or even just their components or different software from those companies. So our financial team is going to be pretty big, but we hope that we have people that are super interested in reaching out to all these different companies, and fostering a good connection with them. So that's sort of the operations side of our team. I just want to quickly touch on, I guess I should have introduced Henry, who's not here, is the operations lead. He would be the one that's generally overseeing all of this, but unfortunately he won't be able to be here for another 10 minutes, so you get to hear me speak. So he wanted me to share just like this quick example of sort of how all these different components touch. So right now we're looking to raise around 100 grand. That's actually shifting to a bit higher as we're fleshing out our budgets, and we somehow have to get that 100 or 120 grand from somewhere. So a lot of that's going to involve, our marketing team showing that our team is as professional and good at what we're doing and producing the things that we say we're producing. That gives our team a lot of credibility. Our internal affairs has to make sure that we're organized enough that we're not all reaching out to the same company and stuff like that. Our financial team has to make sure that we're hitting those targets, we're getting the money when we need it, all sorts of stuff like that, whether it's grants, sponsorships, or money from the school. And then also our community outreach, we have to make sure that we're making a positive impact on the community as well, because companies love to see that. So our whole operations team kind of comes together to make sure that this is possible, whether it's like taking pictures, recruitment, marketing, anything like that. So it's definitely a big complex project with a lot of moving parts, but it's something that's definitely interesting, and it works towards putting something in space, which we all think is pretty cool. So that just about wraps it up. We like to have like little quotes at the end, make it kind of interesting, make it kind of fun. You may have heard of this guy, Albert Einstein. This is one of our big mottos: the only source of knowledge is experience. You're not going to get any of this from a textbook. You're not going to get any of this from a class. They might teach you how physics works, but you don't really know how it works until you actually go and do it. And one of the other big mottos we have is like fail often and fail fast. The reason that's so important is because we want to do things through experience. So you're going to get that on this team. You're going to be able to get your hands dirty. You're going to be able to break things, which is super important because it's the only way you're going to learn. So if you're interested in our team, here's a bunch of social media information. We love to plug our socials. We love to get people following us. I think our goal is to be the most followed Instagram page out of all the engineering design teams. I don't think we're there yet, but we'll get close. So I'll put this back up in a second, but some of you might be wondering, okay, what do I do now? How do I join this team? How do I even just check it out to see if it's for me? So what we're going to do is have you just send your UWO email in the chat. I'll collect all of them at the end, put them into a spreadsheet, and then we'll send you a follow-up email to let you know like the next steps after that. If at any point you're like, hey, this club's not really for me, that's perfectly fine. Just let us know. It's sad to see you go, but we understand there's probably lots of other teams that might be of interest. So I highly encourage at least checking out some of them. But if it is for you, then you're stuck with us. You're good to go. We'll get you situated with a design team or an operations team. We'll get you talking with the leads, and we'll start moving forward to build this thing. If you do have any other questions, you can always reach out to us either right now, by email, by any social medias, and we'll answer any questions. But if anyone does have any questions right now, feel free to come off mute. We'll have a bit of like an open discussion period. If there's enough discussion, we might just like break into breakout rooms, but I think we might be good kind of as we are right now. I saw James just raise his hand. Do you have a question?
Yes, this is actually about things that might go onto the satellite. I was curious if you install anything to do radar or imagery for weather, meteorology data.
So right now, our only like external peripherals will be visible light imaging. The reason for that is it keeps it kind of simple, and it's something that people can tangibly see as like a success for our project. This current mission isn't going to be necessarily very much research based. It's what we're calling a technology demonstration, and it's not so much technology that we're showing, it's more showcasing that undergraduate students can do this completely on their own, and that access to low Earth orbit is much lower than a lot of people will think. So that's going to be the first mission, and then on future missions we'll look at doing more complex payloads. Yeah, Adam.
I was just curious, like on average, how many hours per week you usually put in?
It really depends, and we're definitely open to some people who can only put in a handful of hours. Some of us put in much more than that, but it's really dependent on what you're working on. I would usually budget for like 3 to 5 hours per week, and that includes like going to meetings, that includes like just checking in with your team lead or something like that. But as crunch times get closer and closer, that might kind of shift a bit higher. But we understand people have school. School's definitely going to become a priority. So whatever you guys can budget for, that's kind of what we're asking for.
Awesome, thanks.
Yeah. So just a reminder to throw your email into the chat. I'll take all of those afterwards, put them into a spreadsheet and send you guys an email. I'd expect that maybe tomorrow, but with everything being kind of hectic right now, it might be like Saturday or Sunday. But we're definitely trying to get started really soon. So shoot me your emails either in the general chat or direct message. And if you guys have any other questions, feel free to ask them. I still really wish we were in person. It's so much better to see people, but it's good enough. Actually, I think a lot of our team, like some of our team hasn't even met in person because we started during COVID. So yeah, we've done.
I've only met Dea.
Yeah, so if you guys have any other questions, feel free to ask them now. We'll be just kind of hanging around. Maybe I'll get some more music going, and we'll see where the night takes us. Yeah, James.
The other question I had, you have all these different electrical components in the satellite itself. How are you doing the communication between all of them? Or is that something left to be researched?
So what we're opting for is a decentralized system where each one's going to be talking over a CAN bus. So there'll be a CAN bus that runs up the structure of our satellite, and that's how each of the subsystems communicates.
Okay, gotcha. Thanks.
Yeah, what's up? Or is your hand just still up? Oh, I think your hand's still up. Zoom gives me bad notifications. Okay, cool. I think I've got everyone's emails here. If you guys don't have any other questions, then we can wrap it up here.